Hey, welcome to the first lecture in the Programming in Python series. The plan for this lecture is to sort of give you a little bit of background on how your programming tools will be interfacing with your computer, and a little bit of history on why things work that way, an explanation. And then we'll talk about how to do the installs and how to get code actually working on your computer. So first of all, you're probably viewing this video on a computer or maybe a phone, but more likely a computer. And if you watched the history of programming lecture that I had put out, or put a link to, you might vaguely remember some of the early discussion being about the hardware development of computers. Originally, computers, right, were big things, and in order to change functions in them, you had to physically move pieces and parts around inside the computer to get it to do different things. And obviously these big machines, they would do a bunch of complicated movements with mechanical parts or maybe little early electronic switches and things like that. And they would do a calculation and produce you a number. Very, very simple, rudimentary, but obviously they changed the world. It wasn't for decades and decades that we got to the point where computers could even take inputs from a keyboard. The idea of a keyboard was decades and decades away. And even much later, the idea of a screen attached to the computer, and decades and decades after that, the mouse. So the way you use a computer now is very, very different from how computers were originally built. Fun fact for anybody who thinks this, for some reason, a lot of people believe that Macs were the first computers to use mice. This is not true. Also, Macs were not the first computers to use the idea of a graphical environment on a screen. Both of those developments actually came from Xerox originally, when they were still making computers. But with that aside, you're probably used to using a computer by opening and closing these graphical elements, these windows. And yes, that is why Windows was originally named what it was. These things were supposed to be little windows into your computer where you could view your files and things like that. But you can still fully use your computer without this graphical environment. And how you do that is if you're using a reasonably modern copy of Windows, you can open your start menu or search bar and type PowerShell, which will open you this little window where you will be told where you are in your file system, and you get a little blinking cursor where you can type. You can control all of your computer's functionality pretty much through these text commands, which are standard on Windows. Things like dir, which will list your directories that you're currently sitting in, and there's a big list of these commands to work with PowerShell, And if you're good at them, you can do a lot of functions with your computer that would be very hard to do in the graphical environment. If you're using a modern copy of Windows 11 and you've kept things up to date, Microsoft has also made a point to try to make these commands function the same way as they do in Linux, because many people who many power users who got very familiar with the Linux commands found it hard to move over to the Microsoft ecosystem. So they've tried to make it so you can use, for example, the equivalent Linux command for listing the files in a directory is ls, and now that works on Windows. The Linux command for changing directory is cd. And so if you wanted to go to contacts, which you can see sitting right there, you can change to that directory, and now you'll see that your location is now there. Now you can see what's in contacts, and I have nothing in that folder, so I got nothing back. When you reference files using text like this, you can see your drive location, and then the path of folders down to where you are. If you ever want to go up relative from where you are, you use ... That means up one. And you can change this. You can say I want to go up 2 and write another ... And that would take you up 2 directories. I'm just going to go up 1. And now I'm back to that original location. All of this is not explicitly Python related, obviously, but in order to understand why the sort of basic functionality of the programming language and why a lot of decisions happened with programming languages, you will need to have some amount of familiarity with the idea of working in a command line, which is what this is called, command line or a terminal in Linux. This is just essentially interfacing with the computer via text. And I mentioned it was in some ways a more powerful way to control the computer. That's true, but the reason it's a more powerful way to control the computer is computers were originally designed to be used in this way. Text control existed decades before we had the first graphical environments where you could control with Windows or I actually don't remember what Apple's word for that was, but Windows are what they're referred to as now. But now that you have you've sort of seen what this command line environment is, you might say, okay, so how do I start writing some kind of code? If you were in a Linux environment, you would have some built-in programming languages that you could start running with. We obviously want to start working in Python, and if you were in Linux, you could just start writing Linux. Start up your Python compiler by typing Python. Now, this is a unedited copy of Windows, so what do we think this is going to do? Let's find out. So, Windows 11, at least, and this is a new feature, is smart enough to know that what I'm trying to ask for is to start working in Python, and it's going to take me to this application page where I can download it and install it. But I actually don't want to do it that way. I pointed out in the computer management lecture that like this, the set of software you have in the Microsoft Store is slightly different from the installed software you have on your general applications. So that would install it via the Microsoft Store, and I don't really want to do that. I want to install it and have a little bit more control over what it does. So in order to get that to that, I'm going to come over here, open my web browser, and go look up Python. There we go. This is the Python official website for the developers of Python. We can go there, and we can download Python for Windows. There are a lot of different versions of Python. They've made certain changes to the language that either optimized or added features or things like that. But in order to accomplish that, they have had a couple different releases where they could not maintain compatibility with older versions of the code. Usually programming languages try to maintain compatibility and they just add features. And there are a couple key releases in which Python did not. So we're going to go for the most recent one. If your computer prompts you, you want to keep this. And this is downloading the installer. I'm actually not 100% sure here. If I type Python again, will it just reopen that page? That's very interesting. So now this file is downloaded. We can open it. And it will ask you if you want to open it, and we will say yes. So this installer is a little bit, has a lot of options in it. And I'm going to explain the choices that I make here because I've run Python in a variety of different ways, and I think that these are the best ways to have it installed on a computer that you own. So first of all, we're going to use admin privileges when installing Python, and we're going to add it to the path. What does that mean for somebody who has not used a computer before? The path, and it's usually given in all caps, is the sort of a storage location, the sort of text storage location for references that you want to make available to the computer. What does that mean? If I went into this text environment and I say that I needed to open, say I wanted to open the documents folder, and that is under this at this location. So if I go to document, or if I go, I want to say change directory to documents. It will change me to documents. Makes sense. But now that I'm in documents, what if I wanted to change to contacts? Well, I would have to change the directory back up and then change it again to go to contacts. If I just tried to change directory to contacts, it doesn't know where that is because it doesn't exist. So you have to be in the right spot when you reference something like that. So now you can change to the contacts folder. And you might imagine that that would be a pain in the butt if you, say, installed Python in your downloads folder. Then if you were in any other folder and tried to run Python, you wouldn't know where it is unless you referenced the specific location in the downloads folder every single time you wanted to run it. In order to avoid that, we add it to the path, which essentially makes the computer check when you write Python, it checks to see if it exists in this little sort of shortcut location before it checks if it exists in whatever folder you're in. So it makes using Python a lot easier, and it sort of makes it available throughout your computer. I can go show you these customization options. You want to probably install the documentation. This will let you sort of get access to help on certain error codes and things without having to load them in on the internet. You can just get access to them on an offline file. It's also going to install pip, which stands for the Python. It's a Python package manager. I blanked on what it actually stands for. But what does it do? Similar to how Windows, when it needs an update, will ping the update server and say what are the most current versions of things. It will get an amount of information back from the server, and it will say, do my versions match the most current versions? And if they don't, it will try to update them to match. That done in a more simple way is called package management. Say you have a bunch of different pieces of software and you need to check all of them to see if they are up to date. You do that with Package Manager. So pip is Python's package manager, so that you can download packages of code from the internet and keep them up to date. This will also install tkinter and idle, which are development environments, which we'll talk about in a little bit. Essentially just places that make writing Python code a little bit easier. And it will also install the test suite, which sort of gives you some standard code for testing code. And it will also install the launcher, which is sort of the graphic user environment for managing things in Python. The last option here is to install it for all users. If you are using a computer that is not yours, you don't want to and probably don't want to use this. But for everybody else, if the computer is yours, you probably want to use install for all users. What that will do is make it so that anywhere you open in your file system back on the command line will be able to run Python. Otherwise, you will find that there are locations that are inaccessible when you're trying to code with them, and you might also run into permissions issues. So I check all of those. Next are the advanced options. We just specified we wanted to do it for all users. I'm not sure why that doesn't get clicked by default, but you do want to click that. We're going to associate file types with Python. So just like you might have a .txt or a .jpeg file that you want to open in a specific program, we are going to associate .py files with Python, because that's probably what you want to open them in. You can make shortcuts if you want. Sure. We're adding Python to the environment variables. That is this add Python to the path step that we did earlier. That the path is an environment variable. We're gonna pre-compile the standard library. This is a little bit go a little hand wavy and just say this is essentially, it's making the computer convert the code for all of the standard reading and writing and printing and all of the standard functionality of Python, it's going to convert those bits of code to sort of machine instructions rather than human readable code sort of ahead of time, so that you don't have to wait for it to do that every time you want to run some Python code. I'm also going to have it download the debugging symbols and binaries for Visual Studio. If you don't use Visual Studio, you don't need to do this. And it will also, if you don't use Visual Studio, it will actually ask you to install some bits of Visual Studio to get this to work. So actually, I realize now that I don't have that installed, so I will not take that step. But debugging symbols are useful. And this is a new option that I have not seen. I'm not sure what free-threaded binaries are, so I'm going to just not do that for now. The last thing to note here is the install location. This is actually kind of important. If you didn't install and add everything to the environment, as we mentioned, if you didn't put it in the path, you would have to always reference your Python executable at this location on your computer. We might want to modify or know where it is in the future. So it's good to keep in mind where it actually is. It's going to put it right here. You are free to put it other places if you want, just know where you're putting it. So this will then install Python. It's going to ask you if it's okay to do this with administrative rights, and then it's going to do it. So this should be a rather fast install, because all that we're really doing here is sort of downloading and doing a little bit of organizing and optimizing the files that Windows can point at to interpret some text and convert that text, that code, into instructions for the computer. So it's really not that much that we really need to get this working. All of your basic computer functionality stays the same. You're just sort of installing some instructions on how to control it with a new language, right, in a different way. Most of this actually, this time on this install process is all of the graphical user environment things are a little bit larger and more complicated. The basic instruction set for Python is very small. Oof. It's taking a moment. I will pause the recording and come back when this is done. All right. That did take a while, actually. So it's good that I decided to just pause the video. So once it's all done with that install, it will tell you it's successful. The last thing it asks is if you want to disable the path limit, path length limit. So, I mean, it explains it right here. These text references to locations for some reason are limited in the amount of characters they can be. So we might as well. There's not really a reason that needs to be there. So now we are done, and we now have Python. So now that we have Python on the computer, what happens if we type Python in the command line. Yes, forgot. It opened this up again. Why did it do that? We just installed Python. The computer should now have some sort of idea of where that is. It's because when you open a terminal or command prompt window, they open in a session, and environment variables are actually set usually at the start of the session. And they're not loaded in instantly. So we're just going to close that out. I'm going to open it up again. I'm going to make a sort of intentional mistake here. So we are now back at our location at the command line, and if we type Python, oh, it did something different. So as you can see, it tells you the version of Python you're running, and you're running it on Windows, and gives you a new, slightly different looking terminal. What this is the Python live environment. So when you type something in here, just like in the command prompt, it will read it in. But before it does anything, what it's going to do is try to interpret what you wrote as Python code. When it interprets your code, it will read it from left to right, and eat this string of text that you have written that is somewhat readable, and say, what does that mean in Python language? And it will convert that to something that is in the language more similar, more directly akin to your computer, which is much harder for people to read. This is the basic idea of assembly. Assembly is assembly as a language is direct control of hardware, telling bits of hardware to do specific things. It's not very easy for somebody to read. And pretty much all modern languages have assemblers that involve converting their code to more direct control of computer pieces and parts. You could imagine this is a little bit complicated because, well, computers are built with a variety of different parts. And yes, it is. So it makes it a lot of what Python does under the hood, those things that we downloaded a moment ago, are telling it general ways to communicate with different pieces of hardware, and sort of how to make that conversion from this piece of text that says, that looks like something that we would read as a human, and how to make that into something that actually controls the computer. But most of those intermediate steps are things that you will never need to know. So we won't get too in depth in what they do. Just know that if you type something in here, so I just typed some gobbledygook, and you hit enter, what it's going to do is it's going to try to convert that little piece of text into Python or into instructions for the computer. And when it reads something that it doesn't understand, it will fail and you'll get an error. We have our first Python error right here. What you get with an error is a traceback, which will give you usually an amount of information on where your error was, because you'll later on be programming with something that is very long, could be very long, many lines, even different files. So it will tell you, at line 1 of your piece of your code, you had an error. And it will show you that little bit of text, and it will say what type of error it is. Apparently, it decided this was a name error because that weird string of gibberish that I put in is not defined. So how about we try something that is a little bit maybe simpler? So let's just put a number. Now, before I hit enter on this, we should remember that I've pointed out before, and I'll point out again because we're recording this time. What did computers do originally? They computed. They made a calculation, and they did it in some way faster or better than a human could do it. And that's still what we use them for today, right? They are very, very fast, accurate things that compute. They calculate something for you. Because our computers now are so fast and so accurate, we can do some really crazy things by just computing numbers. We can draw pictures, make the pictures interact with you, track how you're touching things or moving stuff around. All of that boils down to just computing numbers and storing them and reusing them. So if you're talking about what's important for a programming language, what do you want to be able to do with a programming language? Well, obviously you want to control the computer, but in order to control the computer, you want to tell it what to calculate. So just like a calculator, if you pull up your calculator, and in fact I can do this right here, calculator, if you hit 5 and then hit enter, what does it do? It tells you 5, right? You plugged into your calculator, you said, what is 5 equal to? And it said 5. Python, if you type 5 and you hit enter, what will it do? It will tell you 5. So in a way, Python has read this line and it has said, gone right to left, and it said, or left to right, and said 5. And there's almost a little hidden equals sign at the end of each line. And it said 5 equals, and then it spit back out 5. So if at its basic level, Python will calculate things for you and sort of left to right evaluate something on a line, we can also try and see if 5 plus 5 works. Oh, excellent. Python gave me 10. So basically, you can see from here that Python has gone left to right and evaluated this thing that you had and spit you back out the answer. That's great. But as we also found out, it doesn't just work with words. So if I try to write 5 plus 5, Python doesn't know what to do. So what that should tell you is that Python cares a lot about what specific characters you put in here. It's not like an AI or Google search. You have to be careful about what you type in. Now, Python is a lot better at this than a lot of other languages, programming languages, but even being better doesn't mean that it's can figure out anything you put in. So if you look at the error here, it's once again line 1 because we only entered one line. It pointed out for you nicely enough that it doesn't know what this plus, this word plus here means. And the way it identifies that is it says syntax error, invalid syntax. So syntax in programming is just boils down to how things are written. So like 5 plus 5 has a meaning to us, but to the programming language, this is 5 and then some weird gobbledygook it doesn't understand and 5. So it says this is something wrong with your syntax. Just as easily, we can go back and do 5 plus 5 and hit enter, and it will give it back. We can also do 5 plus 5 with no spaces, and it will give us back 10. Python in some ways is almost unique in that in the way that it or sorry, I will say Python in this in a math calculation doesn't care about the spaces, right? 5 plus 5 and 5 plus 5 with spaces is the same thing. But there are a variety of reasons where Python does care about white space, specifically for things like tabs in your code. If you press the tab key, it does care about that. And that is not very many types or not very many languages care about the white space. So if you are looking at other languages ever and you notice that's just I guess a fun fact about Python is you will get used to looking out for white space, where in most other coding languages you don't really have to care. All right. So with all that being said, you have now opened Python. You've installed Python and opened it on your computer. And now you've calculated a couple things and made a few nice little errors for yourself. And you said, I'm done with Python. How do I get out? So in order to leave this live Python environment, you would hit exit. Now, that's all great. Obviously, congratulations, you did your first programming in Python technically. But really what you want to do is write code, right? More complicated things that will calculate more than just one number, because honestly, you could write 5 plus 5 in Google and get that out. It's harder to write this in this way. You're only going to bother doing this if you want to do something that's a little bit more complicated than 5 plus 5. So the next thing you should know about Python is that if you go to, I'm going to just so that I change over to that contacts folder just so I have a nice empty directory with nothing in it. And I'm going to make a new file. So I'm going to do that by opening Notepad. And I just typed notepad.exe into the command line to do that. And I'm going to write some text. 5 plus 5. So it's the same text I put right here in my Python code. But let's add some more in there. Let's say 5 plus 10. 5 plus 15. So now we have a few different lines of things you want to calculate. And we're going to save that. And we're going to put it in the contacts folder. Or not. Apparently that's not available. Interesting. All right, let's put it on the desktop. And we're going to name it test underscore code .py. Now, why did we name it .py? Because we want the computer to keep in mind or anticipate that this will be Python code. So now that we have that little piece of code saved, we can, I guess I have to change directory back to desktop. And when you're working on the command line, something to keep in mind that makes it a lot easier is most command line and terminal tools have what's called tab completion. So if I know that I'm going to go to the desktop and I start typing it and I hit tab, the computer's going to say, what are they trying to type? And it's going to look at all those directories that I've referenced, and it's going to say, desktop is the only option. And it should, maybe not. Sometimes it's a little bit slow on this virtual machine. Interesting. I don't have a desktop there. Inconsistent. I guess we could go move this to saved games. I just want a nice empty directory that I can... Oh my gosh, it's not in there either. All right, I will pause this for a moment and find a location that I can store this. All right, I'm back. I apologize for that. I needed to make sure that my documents folder was not distracting. So we will save it in documents, which is honestly probably where you would want to save it normally. I also made sure that by default, Windows tries to save anything that you edit in Notepad as a text document, and we don't really want to do that. We want to save it as a .py file. So in order to do that, you just tell it you're saving it as a file. All right, so now we have testcode.py, and it should be located in documents. Come on. Why is it so slow? And I can check. Oh my God. What? I... Huh. So if you right click on a file in your file or your file browser and you want to find it, you can go to copy as path, and this is Windows 11, and then you can paste it somewhere. Oh, it put it in OneDrive. Well, I guess there's something to look out for if you are working in Windows 11 environment. Is OneDrive is now like integrated with computers, so it sneaks in to things. Personally, on my desktop machine, I uninstalled OneDrive and in fact deleted all of these file directories that reference OneDrive because I didn't want this confusion to happen, but I forgot that this is a thing. So with all of that behind us now, what is this? This is a reference to this specific piece of code that this little text file that we have given a .py extension so that the computer will hopefully know that we want this to be Python code. And we're going to tell Python to read it. So how do we do that? We say Python and then tell it where your little text file is, and then Python, your computer will open the Python interpreter. It will go through your code line by line and left to right on each line, and it will say, 5 plus 5, I know what that means. I need to compute something on your computer, and I need to compute this value, and it will give it back to you. So we will do that. And it will give us nothing. Why did it give us nothing? Because this code that we have saved here, it in fact did give us back these values, but because we weren't running in the live environment, it suppressed the output for anything that we didn't specifically tell us to give back. It calculated 5 plus 5, 5 plus 10, and 5 plus 15. And what did it do with that calculation? It stored it in memory somewhere and moved on, because we didn't tell Python as a not interpreted this not interpreted bit of code needed to print. So how do we get Python in a bigger set of code? How do we get Python to tell us what it's doing? And in order to do that, we need our first Python built-in function. This is one of the things that's included in that standard library that was compiled earlier during our install. So let's open back up our live Python and say, just so we remember, 5 plus 5, it equals 10. Now, if I, in the live environment, tell Python to print something, 5 plus 5, it looks like the same exact thing. So you might say, well, why do I bother doing that? Well, you now already know the answer to that. In fact, it's because if you weren't in the live environment and you just calculate something, Python will just calculate it and move on. The live environment sort of functions with a hidden print function around everything you do. So it will spit you back these 5 plus 5, the result of these, and it won't bother doing that if you have a big string of code. So let's see if this is true. So let's print 5 plus 5 and then calculate the other two numbers. And make sure that we save it to the right spot. Documents. And we save. It's going to ask me if I'm okay overwriting it, and I say yes. So now, let's exit out of the Python environment. Oop, I misspelled it. And go back. And the other thing that's very useful to know if you're working on the command line for the first time is it has a history. All you have to do is, if you, on your arrow keys, if you hit up or down, you can go look at your code or your commands that you've put in. So instead of writing back out that big long path, I'm just going to press up twice and redo it. And lo and behold, we have Python. We've told Python that we have some text file here, a Python file, that it needs to read in as code, interpret, and convert to something that the computer can do. And what did it find after it converted? It found that it needed to print the value of 5 plus 5 and then do these other two calculations, but we didn't ask it to print them, so it did them and didn't tell us what happened. So let's have Python tell us that it's done. So we could do this by having it print whatever 5 plus 15 is, and then we would know that the computer has finished this bit of program. But let's do something a little bit more traditional. Let's say print hello world. So actually, let's do something a little bit different and just intentionally make a mistake. So I'm going to save this. So let's try to make Python print hello world by rerunning this piece of code. And lo and behold, we got our first error from a piece of from a Python file. You'll see that it looks the same as an error that we got earlier when we typed gobbledygook in. So once again, we have this trace back. It'll tell us it's in this file. It's at line 5, not line 1 this time, because we have a multi-line file now. And it said, well, I understand print. You're trying to do something here, but I don't understand what you're trying to do after print. And why does it not understand that? Because you didn't tell Python that what you're printing here is text. It's going to say hello is not defined. It might make a suggestion. In this case, the suggestion was not very good, right? Did you mean help? No, we didn't mean help. We wanted you to print this text. So in order to help Python understand that what this is text, we have to put it in quotations. So let's save that again and try rerunning this. Oh, there we go. So we have Python has come through our code. It's done a calculation for us and printed the result. And it's also printed out some text that we have. So congratulations. You've now made, if you've been following along, you've now made your first Python code. You've learned how to, for one, install Python. You've learned how to make your computer read things that you're typing as Python code. And you've learned how to tell Python to load a bunch of things that you've typed in and run them all at once. You are now a programmer. Although you only know how to do some basic things, you can now tell the computer to do what you, to calculate or print some things for you to the screen. And it is now, the world is your oyster. So you will have an assignment to do with just these basic little options. I'll post it later, but congratulations. That is all it takes. You're now a programmer. I'm going to be putting out some more lectures. Obviously, we're going to follow the what that was on the syllabus originally. I'll try to put out a lecture for each topic. The next lecture will be setting up probably a little bit of a developer environment and then going over the first bits of how you can convert things to I blanked on my train of thought. Yeah, so the first basics of how you store and reference information in pieces of code later, which is obviously very important. So have a good day, and look for the next lecture, I guess, if you have time.